So this video, I wanted to talk about the properties of fractions. When you're in, algebra, trigonometry, getting down these properties for future mathematics courses like calculus is really important, and it's going to be really important just to get through algebra, just to get comfortable working with fractions. I think a lot of people think fractions are scary, but once you get comfortable working with them, you'll just see them like any other number. So let's go over some of the foundations. So if we have a fraction a over b, where a and b are just real numbers. So a is some real number, b is some real number. We know that a is the numerator and b is the denominator. Meaning b is the divisor. So you can look at this kind of in two different ways, and it's kind of how I look at it. The first way I look at it is that we are dividing A into B number of groups. So if you want to look at an example, let's say, 4 over 2. Which is an improper fraction because the numerator is bigger than the denominator. But it'll be easier to look at an improper fraction since we can get whole numbers as a result, just for the first example. Say we have 4 over 2. So this means that we have 4 boxes is what we have. So the numerator is what we have. We have, say, 4 boxes, 4 of anything, 4 apples, 4, oranges, anything. Here we'll use boxes. And we want to divide them into 2 groups evenly. So to do so, we say, okay, well, here's the first group. And here's the second group. And we were able to do that evenly. So there are 2 boxes in each group. So we had 4 to start with, 4 boxes. We divided them into 2 groups, and we're left with 2 in each group. So that's your answer. 4 divided by 2 equals 2, because when we divided what we had, 4 boxes, into 2 groups, there were 2 boxes in each group. So the number of boxes left in each group is your answer. So 4 divided by 2 is 2. Okay, that's the first way of kind of looking at this. The second way of looking at it is like we're looking at a pizza. So let's say that B is the total number of slices. And A is the number of slices that we have, meaning if, someone eats a slice, what we're left with, there were B total number of slices to begin with, what we're left with is A. So A is the number of pizza slices we have in our possession. So let's make this a visual. So say we have a pizza and we want to divide this into 8 even slices, and that is really horrible. They're not even, but let's pretend that that these slices are even. So we have 1, 2, 3, 4, 5, 6, 7, 8 slices. Okay? So we have 8 out of 8 total slices. So if we have 8 out of 8 total slices, we have 1 whole pizza. So 8 over 8 just equals 1. So there is one property for you. If you have a fraction and your numerator is equal to your denominator, it just equals 1. Because if we have 8 slices out of 8 total slices in our possession, then we have one whole pizza. Okay? So let's say that you eat one of the slices. So if we shade it, it means it's gone. So we've eaten 1 slice. Well, how many slices are we left with? This one's gone, so we have 1, 2, 3, 4, 5, 6, 7. So we're left with 7 slices. So now we have 7 out of 8 slices, okay? Let's say that we eat another slice. So now we have 1, 2, 3, 4, 5, 6. So now we have 6 out of 8 slices. Well, let's try to look at this in another perspective. Let's divide the pizza into fourths. So this is a fourth, this is a fourth, this is a fourth, this is a fourth. So the 2 slices that we've eaten, we see make up an entire fourth of the pizza. So if we eat 2/8 of the pizza, 2 out of 8, we're left with 1, 2, 3, 4, 5, 6/8. But if we're looking at it in terms of fourths out of 4 slices, so this is a whole slice, 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 these 2/8 make up 1/4. So we're left with 1/4, 2/4, 3/4. So we can conclude from this that if we're left with 1, 2, 3, 4, 5, 6/8, it's the same thing as saying we're left with 3/4, right? So we can conclude that the fraction 6/8 is equal to 3/4. Okay, so that's how you conclude that visually. If you want to conclude that using arithmetic, we can say, well, we can reduce these because these have common divisors. 6 can be divided by 2 and 8 can be divided by 2. So if we just divide the top and bottom by 2, which is the same thing as multiplying by 1 because 2 over 2 is 2 over 2 is a whole, which is just 1. So if we divide the top and the bottom by 2, 6 divided by 2 is 3, and 8 divided by 2 is 4. So dividing the top and the bottom by the same number gives us an equivalent fraction as long as you do it to both the top and the bottom. We couldn't just divide the top by 2 and not divide the bottom by 2 because that would be changing the value of the fraction. Here we're just changing the proportion, okay? All right, so now that we can kind of see how we can look at fractions visually, how we can start thinking about fractions, let's talk about the actual properties and how we can work with them when we're in algebra in dealing with fractions in algebraic expressions. So let's go over the properties, the formal properties. So the first property we're going to talk about is multiplying 2 fractions. So if we have a over b, a is just some real number, b is just some real number, and we multiply it by c over d, notice that the denominators here don't have to be equal for us to multiply them. We'll talk about addition where they do need to be equal, but we have a fraction here. None of these numbers are the same, and the way we do this, multiplication is the easiest property. We're just going to multiply straight across. So we're going to do a times c and b times d. So this is just going to equal ac over bd. So just multiply straight across. So let's look at an example. So if we have 2/3 multiplied by 5/7, we're just going to multiply straight across. So 2 times 5 is 10, and 3 times 7 is 21. So we have 10 over 21. Okay, so the second property, and let me just say this one more time. This is for multiplication. One of the biggest mistakes people can make when dealing with fractions is when they're adding fractions thinking that they can just add straight across. They add the denominator and add the numerator. That is not the case. It's only the case with multiplication. This is the only operation where you can just multiply straight across or perform the operation straight across the numerator and the denominator. Okay? So the second property is going to be a over b divided by c over d. So we're going to talk about division with the second property. Now, this is going to be a little bit different than multiplication. We're not just going to go straight across and divide A divided by C and B divided by D. What we're going to do is the property is that A divided by B is divided by C divided by D is the same thing as saying A divided by B times D divided by C. So what we do when we divide by a fraction, we can multiply by its reciprocal. So just when we see a fraction divided by a fraction, we just flip it and we'll get the same thing. So for example, here if we have 2 over 3 and we divide it by 5 over 7, this is the same thing as saying 2 over 3 times 7 over 5. And now we can just use the previous property of multiplication and just multiply straight across. So we're going to get 14 over 15. Okay? All right, so let's move on to the next property. Third property is going to be A over C is addition plus B over C. Now notice that this denominator is the same. So what we do when we are adding is if we already have a common denominator, we just keep that denominator, because if, say, I have A slices of pizza and my friend has B slices of pizza out of a total number of C slices of pizza, then we're not going to add our total number of slices up. We're not going to go C plus C. We're just going to, we remain with the same number of total slices possible, but we can just add my slices to her slices, so A plus B, okay? So keep the denominator the same. If they're already a common denominator, just carry it over and add the numerator. So if we have an example here, 2 over 5 plus 7 over 5, so we're just going to add the numerator. So we have 9 over 5 here, and we keep the same denominator. All right, so let's go to the fourth property. The fourth property is going to be the property when, in addition, adding two fractions, when the denominators are not the same. So we have A over B plus C over D. What we're going to do is find a common denominator, and this is not going to be the least common denominator, but this property shows how we can just find an overall common denominator by just multiplying this fraction by this denominator and this fraction by this denominator, meaning we're going to have a common denominator of B times D, okay? Because if we have a common denominator as B times D, we have B has B in common and D has D in common. So then what we do is we're going to multiply, because we want BD a common denominator. In this, we only have the B. We still need the D. So we're going to multiply this by D over D. Okay, so now we're left with AD. Okay, so we have AD plus, and we're going to multiply the left fraction by B, because in our common denominator we have a B and a D, but in this we only have a D. Remember, what we do to the top, we have to do to the bottom. So we're going to multiply this by B over B. Okay, so now we're left with BC. Okay, so let's do a quick example. If we have, let's say, 2/5 plus 3/7, we're going to multiply the left by 7 over 7, and we're going to multiply the right by 5 over 5, because we want our common denominator to be 7 times 5, okay? So then this just equals, okay, now we can just use our property 3. 7 times 5 is now our common denominator. So we have 7 times 5. And now we have on the numerator 7 times 2, which is 14, plus 3 times 5, which is 15. Okay, so now we have 29 over 35. All right, So our fifth property is just going to talk about cancellation. So when we have a fraction, say AC over BC, remember when I said if you have a numerator and a denominator that are equal, it just equals 1. So if you have 8 out of 8 slices, you have 1 whole pizza. Well, here, multiplication, because we can factor things in and out of multiplication, we can cancel this C because this C and this C over C is just 1. They cancel. So writing AC over BC, because there's a common C in each, the numerator and the denominator, they cancel out. They just equal 1. And it's the same thing as writing A over B. So we can say 2 times 5 over 3 times 5, or 10 over 15, is the same thing as saying the 5's cancel, same thing as saying 2/3. Okay? The final property here is just talking about when we're going to write an equality expression. So if we say if A over B equals C over D, one really common mistake here is assuming because the fractions are equal that the numerators and the denominators are equal. But this statement does not imply that A equals C and B equals D. What it does imply is that AD equals BC. And the way we got that is just by cross multiplying. So we said A times D and B times C. Okay, so you cross multiply to get equality when you have two fractions equal to each other. Okay, so here if we have an example, if we have 2/3 equals 6/9, well here we can obviously see that 2 doesn't equal 6 and 3 doesn't equal 9, but we can say by cross multiplying these two and these two that 2 times 9 equals 3 times 6. And we know that these are both 18, so that checks out. Okay, the very last thing I wanted to talk about in this video is kind of an extension of property 4. So here property 4 is a way to find a common denominator, but is not the least common denominator. So it's not always going to be the most efficient way to find a common denominator. What we want is instead to rewrite the fractions so they have the smallest possible common denominator. And we call that the least common denominator. So let's do, and this common denominator is often smaller than the product of the two denominators. So I'm just going to do a quick example. So this is an example of least common denominators, okay? So let's say 5 over 36 plus 7 over 120. Well, we could, like we did in property 4, just multiply 36 by 120 to get a common denominator and multiply this by 120 over 120 and this times 36 over 36 and then add the numerators. That is perfectly fine. You can do that, but 36 times 120 is a pretty big number, and we know that there's probably a smaller denominator that we can use. So it's a little more efficient to use it this way. So the way we're going to find what is our least common denominator, what is the least number that these have in common, is we're going to use a factor tree. So if we have 36 here and 120 here, and let's break these up into factors. So 36 is 4 times 9, and 4 is 2 times 2, and 9 is 3 times 3. And 2 and 3 are prime, which means they only can be multiplied by 1 or the number itself. So these are in the least form possible. So 36 is equal to 2 squared times 3 squared. Okay, so 120 is 12 times 10, 5 times 2, 3 times 4, and 2 times 2. So here we have 1, 2, 3 2's. So we're going to say, 120 is equal to 2 cubed, because we have 3 2's, multiplied by 1 3, so just 3 to the first, or 3, multiplied by 5. And how we're going to find the least common denominator from this is we're going to take each factor, so 2, 3, and 5, and we're going to take the one with the highest exponent from each. So the LCD is going to be the one with the highest exponent. So for 2 here, 2 cubed is higher, so we're going to take the 2 cubed. 3 squared is higher than 3 to the first, so we're going to take the 3 squared from here. And then we're left with 5, so times 5. So the least common denominator is 2 cubed times 3 squared times 5. So this is 360. So that's our least common denominator. So now we can get this in a form that we can add them together. So we know we want the denominator to be 360. So we need to multiply 36 by 10. And what we do to the bottom, we have to do the top. So 10 over 10. And we want to multiply 120 to get 360 by 3. And what we do to the top, we have to do the bottom. What we do to the bottom, we have to do the top. So 5 times 10 is 50. And we know 360 is our common denominator. And 7 times 3 is 21. And that's over 360. So now we have a common denominator. Now we can just use our property 3, because these are the same, so it's going to carry through because we're adding. So the denominator stays the same, and then we add the numerators. So we're left with 71 over 360, and that's the answer. Okay? So this whole process, if you're just seeing it for the first time, takes a little bit of practice to get it down. So what I'm going to do is give you guys a couple of problems that you can work on, and I'm going to put an answer in the comments section. So here's some problems to practice, because just watching me do it once is not, you're not going to get it down from that. So first, add 3/10 plus 4/15. Second, subtract 2/3 and 3/5, so 3/5 minus 2/3. Third, 1/4 plus 1/5. And a fourth problem, do 1 plus 5/8 minus 1/6. This might be a little tricky, but a hint here, remember, this is just 1/1, because a whole number is just when the numerator and the denominator are equal. So when you're finding common denominators between these three, just know that's 1/1. So it can be multiplied top and bottom by any number to get it the same as these two common denominators, okay? So just try these 4 problems, or try 2 of them, just try 1 of them, do a little practice on your own, and I'll put the answer to these in the comment section of this video, okay?